We're looking at problem 1 from Midterm 1 of the University of Washington's Winter 2016 Math 120 course. This is pre-calculus. And the first question asks us to consider Electra, who stands 40 feet west and 15 feet north of the center of a circular puddle. And she begins running east at a speed of 10 feet per second. And it gives us one more piece of setup information. It says after t seconds, the puddle has a radius of 8t feet. So the puddle is growing with respect to time. And the question asks us to find two things. First, it asks us to find how long Electra spends in the puddle. And then it also asks us to find how far she travels while she's inside the puddle. So let's see if we can answer those two questions. If you haven't already, take a minute and pause the video and see if you can answer them for yourselves. So as with most questions in this course, we'll start by drawing a picture. So we have some puddle, and Electra's position is given with respect to the center of this puddle. So let's say that we have here some center of a puddle. And Electra is currently, at the beginning, 40 feet west and 15 feet north. So let's say maybe 40 feet west and 15 feet north. This is where Electra is starting, and this is the start of my puddle. And let me, while I'm drawing this picture, also begin to impose a coordinate system onto this picture. It seems to me natural to use the center of the puddle as the origin. So let me just label this as such. And Electra is now, I can describe her coordinates as negative 40, comma 15. And this is what's going on at t equals 0. And at t equals 0, the puddle is currently has a radius of 0 feet. So the puddle is just a little tiny dot, not even that, I guess, at t equals 0. And with these moving pictures, I like to kind of maybe draw what it looks like at t equals 0, and maybe a second later I'm curious also what this is going to look like. At t equals 1, what's going on? Well, Electra is traveling east, so I'll switch colors for this situation with t equals 1. At t equals 1, Electra has traveled 10 feet. So her new position will be here, and this will be negative 30, comma 15. This is, I could say maybe this is e sub 0, and this is e sub 1, Electra's position at time 0 and Electra's position at time 1. And now the puddle has grown. At t equals 0, the puddle is currently 8 feet. So the way that I've drawn this, I have this being 15. It looks like this is a little bit lopsided, but I'm imagining that this is the center of my circle. Maybe I'll move it down a little bit to make it look a little more accurate. And this has a radius of 8 feet at t equals 1. So I can imagine as this picture continues to play out, the circle is going to grow, and Electra is eventually going to cross the circle. I need to somehow come up with a specific description of when Electra will enter the circle and when Electra will leave the circle. So let's see. What can I say about this circle? Because I chose the center of the circle to be the origin, my equation for my circle, my puddle, is going to be somewhat straightforward. I'll put this here. The equation that I know for the circle is, in general, x minus h squared. In this case, h and k are both going to be 0. So I can really write my circle as x squared plus y squared equals r squared. And what I know is that this r, I'm used to it just being a constant, but here this r is actually itself a function of t. So I'll replace this r and instead write this equation for the boundary of the puddle with respect to t, I can say is x squared plus y squared equals 8t squared, or maybe a little bit simpler, I could write this as 64t squared. And what do I know about Electra's position? I'd like to say Electra's x coordinate as a function of t and Electra's y coordinate as a function of t. So Electra's x coordinate I'll express like this. Her x coordinate as a function of t is starting at -40. And with each second that she runs, she travels 10 feet. So I can write her position, her x position, like this. And her y position is quite a bit simpler. At any given t, whether you tell me t equals 0 or t equals 10, her y position is always 15. So now I have the parametric equations for Electra's motion. Her x position is a function of t, her y position is a function of t. And I have the boundary of the puddle also expressed in terms of t. So I can combine these equations in order to find the times when Electra's position will intersect with this boundary of the puddle. So in particular, if I take this statement of x and this statement of y and plug them in to here and here, I get an equation that's just in terms of t. So I now have, if I substitute in, I have -40 plus 10t squared plus 15 squared. This x squared I replaced with the expression for x, and this y squared I've replaced with Electra's y position. And I have that this equals 64t squared. So from here, it's actually quite straightforward to compute what values of t will have this hold. Squaring this, I find 1600t. This is -400, so that 1600 was from the 40 squared. There shouldn't be a t on that. Here I get -800t, and I get plus 100t squared. This comes out to 225, and this equals 64t squared. I can subtract 64t squared from both sides, and then I simply have a very familiar quadratic equation. I can write this as 36t squared, let's see, minus 800t, and now this combines to plus 1825 equals 0. So I can now, using these coefficients, directly plug this into the quadratic equation. If I'm using a calculator, I might do that now. I might also look to see whether I could factor a term out of this, just to make my life a little bit easier when actually working through the square roots. In this case, off the top of my head, I don't see necessarily a common factor. Yeah, I don't see a common factor of 36, 800, and 1825 off the top of my head, so I'll just go ahead and plug it into the quadratic equation. I get that t equals -b, so 800 plus or minus, and now we're looking at the square root of b squared minus 4ac. So 4 times 36 is 144. And all of this is over 2a, which is 72. So the question actually asked us to find how long she spends in the puddle. There's two solutions for what we get for these t values. We'll find one t value is 800 minus this square root over 72, and the other one is 800 plus this square root all over 72. So the difference between those two t values will give us exactly how long she spent in the puddle. then to finish this off, we're also asked to find how far she travels when she's in the puddle. This is simply a matter of taking these two t values, plugging them into Electra's position. We'll find her position at the first t value, her position at the second t value, and then simply use the distance equation to finish things off. So I'll hold off on actually running through the final computation and let you handle that yourself. From here, it's just a matter of plugging in some numbers and actually calculating things.